Good evening everyone. I welcome you to this session. Yesterday we were having a quick discussion about metrology and today we are going to continue with that. I hope you are really doing awesome in there, and I believe that we are again going to have a very scintillating, energetic and informative session here. Okay, we are just going to go through very basics, and because I have already told you that you need to do basics first, right? Basics come first and then questions are next. So this is what I can tell you. Okay, so let's get started. This is me. My name is Rahul Kanyal. I have had the experience of working in a PSU company called BHEL. I have a master's degree from IISc Bangalore as well. Fine, so we are coming up with these live analysis of ESE 2020 on 5th of Jan. So if you want, you can tune in. Fine. We also have a mega mock challenge, as can be seen over here. Good evening everyone. Good evening. Dimple, Rahul, Shiva, Wasim, Prasad, I welcome you all over here. Okay, fine. So number of days left are 15 for ISRO. So how are your preparations going? Is there anything that is bothering you? Any confidence issue, any anxiety issue, anything? You know, I can help you with that if you are having problems, psychological issues and all. Okay, but we are not going to talk about that here. We are going to talk about few basics as we talked yesterday. Okay, fine. Yesterday we were having a discussion about basic metrological terms. So let's start with something called basic tolerance unit. All right, this is also called standard tolerance unit. Okay, good evening Shahrukh and Vikas. Okay, so let's get started. Fine. So first question comes up, why tolerance? Can you answer this quickly? Why do we need tolerance? What is the need of tolerance? Can you please answer this? Please type in there. Good evening everyone. I welcome you here. Again, I have to reiterate it. So why tolerancing? Why do we need tolerance? You must understand it, okay? Maybe a question comes up over there. And a 1 marks question can elevate your ranks by thousands of ranks, because nothing can be exact dimension. Yes, exactly. Abhishek said that nothing can be made of exact dimension. Nothing is perfect, right? Everything has constraints, limitations. That's why we need a tolerance, right? A minimum value of shaft and a maximum value of shaft. Let's say if you are talking about shaft, right? And yesterday we have had a talk about that. Okay, now there's something called basic tolerance unit, and it's given by 0.45 d to the power 1 upon 3 plus 0.001 d, and its units are in microns. Okay, now when I have told you that I is calculated in microns, can you guess the unit of D over here? Can you guess the unit of D? What should be the unit of D? Mm. Yes, he is right. D should be in mm. Why? Because this is multiplied by 0.0001. Yes? Okay, fine. Good. Abhishek and Bhaskar, you're right. It should be mm. It cannot be microns, right? Now, this is a question that came. Standard tolerance unit is equal to. Now, you can tell it very easily. And we will come why we are calculating this, okay? We will have a topic about this. Good evening, Sonia, and good evening, Shiva. Okay, so can you please answer this? Standard tolerance unit it's C. Yes? Bhaskar also says C. Okay, fine. We will have a discussion why are we calculating this. But for now, what's the answer? Yes, please keep on answering. C. Okay, fine. Good. Okay, so I said that I equals 2.45 d to the power 1 upon 3 plus 0.001 d, where I is calculated in microns and D is calculated in mm. Now there's a condition for this, okay? You should always know where is this applicable, okay? So this is applicable only with basic size. Yesterday we were having a discussion about this, right? We talked about basic size yesterday. So this is applicable only when basic size lies in between 0 to 500 mm, okay? Please have a note about it. And this will be equal to 0.001D plus 2.1 if basic size is lying in between this. Okay, so please have a note about it. Fine? Please note this. Yes, this is also applicable for gate. This is applicable for everything. All right? So, okay, yes, most of you got it. C is the correct answer. Okay? Fine? Yes, everyone? It's good, yes, if you remember these formula at least, because you know these questions keep on recurring. Revu, I have answered your question. Okay, Karthik also says C. Okay, C is the correct answer as I have told you. Okay, fine. Yes. Now, why do we calculate it? Why do we calculate it? For example, you want to do milling, okay? Then it has been suggested that for doing milling you use IT9, IT10 to IT13 grades. Okay, grade is nothing but a suggestion that for milling you need to use these grades. And why these grades? Why grades? To calculate tolerance. All right, IT stands for international tolerance. All right, now for example, if I say there's a shaft called 50F5, okay, this is very important. Please take note of it. This means that 50 mm is basic size and IT5 is the grade. Please make a note of this, okay? This can come, okay? Okay, fine? Yes? Yes or no? Okay, grades are just the suggestion for a manufacturing process, as I have given you the example. For milling, these are the suggestions. That's all. Okay, and for IT5, the tolerance equals to 7 into I. Okay, fine. This F, see, capital letters are generally used for holes generally, but sometimes they use it for shaft as well. Yes, won't capital, yeah, you're right. But sometimes, you know, I was watching a question of gate there, they had mentioned this thing, that they had specified it's a shaft, so they'll specify it. If they don't specify it, this means a hole. Yes, you're right, exactly. Okay, so if I say small f, then it's understood that it's a shaft. Fine. So for IT5 the tolerance equals to 7i. That's why we were calculating I. It's very important you understand why do we calculate I. Yes? Is that good? Should we move ahead? Say yes if you want to move ahead. I think this is clear. Yes? Yes, small f should be shaft. You're right. Is that good? Fine, fine, fine. Good, good, good. I hope you're really energetic out there. Yes. Okay. Plug gauge is used to measure. Can you please answer this? Can you please answer this? B. Let me show you a picture of plug gauge, okay? Then you'll be easily able to answer this. Plug gauge looks like this. All right? Yes? So what do you think it should be? Taper bore, cylindrical bore, spherical holes, none of the above. B, B, B. Karthik, I think I am not the right person to reply to this. I think the management should reply to this, okay? And yeah, I'm entirely new to this Gradeup company, and I'm doing whatever I can do. Yes? Okay, B, 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 B. People are saying C also. See, I had shown you this plug gauge. One end should be a go and yes, both go and no go in one plug gauge. It's possible. Okay, let's say this is go, this is no go. So what do you think should be the profile of the job that can be tested using these? It should be cylindrical bores. Bores are nothing but holes. Okay, generally bores equals to holes. There's another name for holes that's called bore, generally speaking. All right. Yes, Abhishek, both go and no go in one. Yes. Yes, wear allowance will be given in go only because it's in the contact. It goes inside and it takes on the wear. So wear allowance on the go only. Okay, fine. Yes. So cylindrical bores is the answer. Fine. So spherical holes. See, it looks like this. The profile, Deepak, I am answering you. Okay. If it would, the profile would be spherical instead of cylindrical, the profile would be spherical, then it would go inside a spherical hole, right? Yes or no? This is very logical, right? That's why not C. You're saying spherical holes. It doesn't look like sphere to me. Yes, it looks like a cylinder to me. That's why I have included the picture. That's why P we say. Okay. I hope this is clear. Fine. Now this is called a snap gauge. What do you think can we measure through this? Can you please answer it there? This is the picture. This is called snap gauge. What can you think can be measured using this? Please answer. Come on, come on, quickly. Sharmila says shaft, Deepak says dia, okay, and difference between dia, okay, fine. You say thickness of, yes, thickness, OD, yes, good, thickness. Okay, roundness, external dia they say, spherical, thickness, okay, fine. Yeah, when you look at it, see, when you look at it, if you can, yeah, so I'll take thickness and outer dia, all right, but generally snap gauges are used to measure outer dia of shafts, okay. But yes, you're right that, you know, it looks like thickness can also be measured using this. But looking at this profile, okay, this is used for external dia of shafts. So please remember this, snap gauge is for shafts, not for holes. Is that good? Can hole be checked in this? No, right? Because of the profile. Yes? Yes? Hello? Okay, now this is ring gauge. What do you think? Can we measure through it? I'm showing it to you so that you always remember, because you remember through pictures, right? External dimension of, Shiva, external dimension of what? Now this is very evident, shafts. Satish says shafts. Okay, shaft dia, fine. And more, I want more answers. Come on, guys. Outer dia, yes, yes. So this is also for shafts. This also you remember, okay? Just take this picture in your mind. How does a gauge looks like? It will be really easy to you. Okay, fine. Yes, you are right. All of you are right. Saurabh, Abhishek, Mageshwaran, Sharmila, all of you are right. I congratulate you. Okay, you're doing really great. Fine, good. Sachin, internal dia and outer dia. Okay, you're saying internal dia. Okay, fine. Internal dia can also be measured, right? Using this. Okay, fine, fine. So just keep this in mind that this is used for measuring the diameter of shafts. All right, fine. Exclusively it's for outer diameter. Okay, but this way, if I tell you that this is the ring gauge exactly, so maybe you can also measure internal dia. Fine. Okay, now what do you think about this? Just look at this. This is called threaded ring gauge. What do you think? What do you think can be measured? Come on, come on, come on. Shaft, you say. External dia, you say. Threaded shaft, he says. Yeah, he's very much, he says pitch of threaded shaft. Okay, fine. Okay. Inner dia, thread dia. And I just want you to understand that whenever we are talking about gauge, we are not measuring it, okay? We are checking it. This is very important concept. Okay, right. So we can say that, see, pitch, again, pitch and all needs measurement. We are just checking it, that the job is correct or not. For example, let me go back to this. Okay, for a hole, if this goes inside, we say that, okay, acceptable. And simultaneously, if doesn't go inside, we say that it's acceptable, right? This is what we say. This is the only condition. Okay, fine. Yes? So we are not measuring anything, we are just checking. We are just checking if the manufactured product is acceptable or not. Fine? Yes? Okay. Plug gauges are used to, now, can you please give me the option? C, okay. No, Abhishek, as I told you, we are not measuring anything. We are just checking. Gauges, gauges mean that we are just checking it. We are just finding out if it's acceptable or not acceptable. That's all. Gauges are made just for this, for the sake of elimination of measurement. That's all. Okay, fine. Yeah, Abhishek, I have taken it from somewhere. It is a very common question. That's why we are discussing it. It's fine if it's asked in GATE. Okay. Okay, fine. So yes, check the diameter of holes in the workpieces. This is a general answer. All right. So every one of you, I think you got it correctly. So congratulations. Okay, you're doing really great. Fine. Okay. Now you can look at this. We are going to have a live analysis on 5th of Jan, right? Yeah, so you can tune in and join us there. Now, surface roughness on a drawing is represented by. Now this is a general question, okay? This is a very general question. You need not study about it, okay? Yeah. So please come up. A. And even 1 mark question can elevate your ranks. This is what I keep on repeating and reiterating. A. Okay, fine, A. Suraj also says A. Manoj says A. Ashish says A. Okay. Okay, Abhishek says ulta triangle. Okay. So is it going to be straight triangle or ulta triangle? Inverted or normal triangle? Is it going to be this? Or this, or this? Which one of these is correct? Which one of these is correct? Okay, fine. Abhishek, Ashish says ulta. Okay, okay. And Bhaskar says inverted. Okay, so this one, like let's say this is A, this is B, and this is C. Ulta. ठीक है. ठीक है. Second. Okay, fine. So this is the correct answer. And let me ask you another question. Let's say first process gives 1 triangle finish. Second process gives 3 triangle finish. Okay. Which one of these is smoother? Yeah, Deepak, I'm trying my best. Okay. So I asked, there are 2 processes. First one is represented by 1 triangle finish. Second one is represented by 3 triangle finish. Which one of these is smoother? Okay. Is that good? Okay, so please come up with options. Which one of these is smoother? This one or this one? A or B? Come on guys, you can do better. Second. Yes, second is the correct answer. This gives, the more the triangles, the more smoother it is, okay? It's B. Is that good? Okay, fine. So here, no, it's B. The B is going to be more smoother. This is what it means. Okay, fine. Yes. See, just one point entered my mind right now. If you're not completed the course, this is another way of doing it. Okay, firstly, you go to a question, do it, then dig more about it, find more information about it, try to understand more about it. All right? Yes? Okay. Now, waviness of a machine surface is caused only by the, can you please tell me? Waviness means, see, when we are talking about surface finish, a surface can have waviness and roughness. Okay, this is what it means. So waviness is caused by which factor? This is what it's asking. So please come up. A. Okay, Deepak says A, Ashish says A. So those who are saying A, can you please explain it? Why? Why do you think that this will cause waviness? Waviness means something like this, a profile, right? Roughness means, obviously roughness means what we call khurdura, right? Not very smooth is rough. Yes? Okay, so can you please tell me, if you are saying A, yes, if it vibrates, then what happens, Deepak? B. Okay, Bhaskar says B, worn out cutting tool geometry. C, Desh Raj says C, Dheeraj also says B. Okay, Shiva Gupta says A, it will produce wave. Yes, Deepak, you are right. Good, I like that. You have intuition. This is called intuition, right? Being able to understand something with pictures and intuition. So this is going to be A, because let's say a machine tool vibrates like this. Okay, actually it will be vibrating in all three directions. All right, then that will cause this. Yes, yeah, Deepak, you're welcome. It's good. It's a good thing to have. Intuition we are talking about here. Okay, fine. So waviness will be caused by machine tool vibration. Okay, is that good? Is that good? Now what we'll call worn out cutting tool geometry? Worn out means the tool is not very sharp. Okay, A is the answer for this. Are you getting this? Are you getting this? Yes? Okay, so worn out cutting tool geometry will contribute to waviness or roughness. Please come up, please come up. Yes, Hiten says roughness, it will be rough. Dimensional inaccuracy, roughness. You know, we are just talking about these two terms. I am talking about this. Worn out cutting tool geometry will give rise to roughness or waviness. It's very intuitive, right? It's very common sense. For example, when you don't have a very sharp knife, right? If you cut something, let's say a potato, what will happen to it? It will be rough. Yes. So almost everyone is saying roughness. Yeah, you're right. It will cause roughness. Okay. Now, can you please think about this? Excessive heat generation during machining. Excessive depth also increases roughness, you say. Yeah, might be. Yes. Roughness. Yeah, roughness is the correct answer for this. Okay. Now you can think about these things. Why I am telling you this? This is why, because he's saying why it will be rough. For example, you don't have a very sharp cutting tool. The sharpness is not there, so it will tend to scratch it, right? That's why it will be rough. Roughness is the correct answer. Okay, so please try to understand the things. All right, well, what happens when excessive heat generation happens? Build the wedges. No, just talk in terms of these. Can you relate excessive heat generation to waviness or to roughness? Built up edges, tool deformation. Okay, those things obviously are going to happen. Tool life decrease, yes. So what happens to waviness or roughness? Just think, okay, just think. Change the properties, yes, you got it right. It will change the properties of material, Wasim, yes, good. And then what happens? Actually, it will change the localized property of the material wherever the heat is happening, right? So what happens? It melts. Need not melt, but yes, the microstructure might change. So because of microstructure change, what might happen? It might become brittle. Okay, you're heating it and suddenly, you're cooling it. Yes, So that will cause, and brittleness will cause what? What might it cause? It will cause roughness again. Yes. For example, I heat this marker locally over here, just at one point over here, or at the circumference. What do you think will happen to it? Will it become rough? See, try to take examples from real life. I'm saying I'm going to heat it in the circumference like this. Will it become wavy or will it become rough? It will become rough, right? So please correlate. Yes. So whatever way you are able to visualize it, you please correlate. So the answer is going to be rough. It's going to be rough. So understand everything. Okay? Intuitively. Otherwise, it will become really difficult here in production engineering to get to the right answer. Fine? Okay. Yes? Okay, radial contraction and all, you are saying that, but I just want to answer in terms of waviness or roughness over here. Okay? Fine. So, Abhishek, as I have told you, we don't measure something, right? We don't measure something using gauges. Those are dial indicators that we use. Okay? Are you getting this? We are not measuring anything using a gauge. We are just accepting the job or rejecting them. That's what it is, Abhishek. Okay? Okay. Yes, it becomes rough. Fine. Okay, Abhishek, I am glad that you are getting it. Okay? But you need to stick with your theory. If different books are giving you different options and answers, you have to be with yourself, with your theory. That's all. That's how you understand it. Yes, Deepak, I'm really sorry. You got stuck up there. The ability of positioning system to return to a previously defined location is measured by its. Now, please, I want answers for this. I want answers for this. What is it? Positioning system to return to a previously defined location is measured by its. Now it's going to be a trickier one. Okay. Yes. So please write in your answers over there. Let's see how we do. Okay. Is it accuracy? So lots of people are saying A and D. Few people are saying resolution. Okay. Control resolution. D, repeatability. Okay, fine. Everyone's okay. Most of you are in between this accuracy and repeatability, right? So what is the meaning of accuracy? When do we say that something is accurate? This is, okay, let's say this is target and we are talking about playing a dart game. Okay, so the closer your dart is, we say that it's accurate. Yes, agreed. Now let's say this is again target, but repeatability has nothing to do with hitting the target. Always remember this. Repeatability has something to do with, repeating the results again and again. This is repeatability. Yes. Now you says how close to actual value, that's why we have tolerance. Saeed, okay? So it's actually, it's a bit, it's a bit it's not a very clean question, because the language is very much confusing. To a previously defined location, it doesn't talk about target value. That's why it's repeatability. All right, that's why it's a repeatability. There's nothing like target that has been specified over here. If you assume that previously defined location is called target, then you are going to take on accuracy, right? Sahi, the answer you, how close to actual value is, that is defined by the tolerance that we give. All right, that's why we have the concept of okay, fine. Is that good? Yes. Now let's start this CAD. Okay. Now let me give you one suggestion, because metrology is too much, okay, and you have to do lots of cramming in there. So go ahead if you want to cram in things. Okay. For example, this job is measured by using this probe, let's say. So there can be lots of crammings out there. There are very lesser basics and understanding in metrology. So you please go ahead and cram them. The more, the better for you. All right. Okay. Now let's start the concept of CAD. Okay. So can you please answer this? Find the new point when 1, 1 is rotated anti-clockwise by 90 degrees. Okay, Hiten says minus 1, 1. 1 minus 1, 1, 0. Okay, minus 1, 1. Okay, minus 1, 1. Fine. And more, minus 1, 1. Minus 1, 1. Okay, okay, okay. So how could you calculate it? Firstly, you make this 1, 1, all right, and this is x, this is y. Yes? Okay, now I'm going to tell you there's something called a rotational matrix. Okay, this is called rotational matrix. And why this is called rotational matrix? Because if you multiply a vector through this, the result is rotation of a point in anti-clockwise direction by angle theta. Okay, fine. Are you getting this? Are you getting this? Yes, we'll talk about it, Deepak. Just hold on. Okay, there are tricks for 3D as well. This is just for 2D. Yes, I agree. So we'll come to it. We'll take up a question, then try to understand this. Okay, now anti-clockwise. Now here theta is 90 degree, so minus sine 90 degree, sine 90 degree, cos 90 degree. This is the rotational matrix, right? So I'm going to write it here, 0 minus 1 1 0. Okay, now I need to multiply. I'm going to take this matrix 0 minus 1 1 0 and 1 1, because this is the point that I need to rotate. Yes, 1 1 was the point here, 1 comma 1. So I have written a vector for 1 1 like this. All right, so what do we have here? -1 and 1. Yes, sign convention is that if you want to rotate it anti-clockwise, this is what we follow. If we want to rotate it clockwise, then what do we do? What do we do? Yeah, this is for anti-clockwise. So for clockwise, I am going to write theta equals to minus theta. I am going to replace in this. Okay, so it will become rotational matrix is going to be cos theta sin theta minus sin theta and cos theta. Is that good? Yes? Is that good? Yes, you can take the transpose of that. That is actually the transpose of this matrix. Is that good? Hello? Is that good? So what's the answer? The answer is -1, 1. Not 1 minus 1. The answer is -1, 1. Okay? Okay. Okay, fine. Is that good? Hello? Is that good? Now, we have to understand, when is this working? When is this working? So -1, 1 is the answer. Okay? It will work when we are trying to rotate a vector like this about origin O. Okay? This you need to keep in mind because the next question is going to be a bit tricky. I hope this is good. Alright, so can you please read this and try to figure it out? Please, come on, come on. About P, you have to rotate by an angle alpha, all right? And sine alpha, cos alpha are given to you. The new coordinates of the vertex Q are. Now what? Now how do you do it? Number 1 point. Can you please tell me how do you approach it? Come on, come on, come on, come on. I hope you're there. Are you there? Everyone. Okay, 3D we are coming up. Let's see how we do. Okay. We'll take a few easy questions from 3D, then try to understand it. Okay? Okay. So what's the answer for this? Please do it. If you understood the first one, you're going to understand this one. You will be able to do it. Shifting triangle to origin. Yes, you're right. Exactly, Hiten. I congratulate you. Very nice. Good. Yes, yes. That's how it's going to be. Yes. Translation to origin, rotation, and again translation. Good, Abhishek. Yes. Very nice. Nice. Good. So please do it. So what they are saying, that you need to have a coordinate axis like this, a coordinate system like this, then only you will be able to rotate it about P. Yes? Yes? So, okay. Kavan says that it's A. So, let's try this, okay? Fine. So, if we do it like this, this is going to be a new coordinate system. This is going to be P, 0, 0. We are going to see what's going to be the coordinate of Q. Can you tell me? If P is 0, 0, what should be the coordinate of Q? Can you please tell me? Come on, come on, come on. What should be the coordinate of Q with reference to this new coordinate system? Deepak says 3, 2, because from here, right, this is 1, 4, 4 minus 1 is 3. Yes, 5 minus 3 is 2. So Q will have this coordinate 3, 2. Yes. Okay. So you need to rotate this Q in clockwise direction. Sin alpha, cos alpha are given. Yes. So sin alpha equals to 0.6, cos alpha equals to 0.8. Sin alpha equals to 0.6, cos alpha equals to 0.8. So what should be the rotational matrix? Cos alpha, sin alpha, minus sin alpha, and cos alpha. Yes, because the rotation is in clockwise direction. Yes. Okay, good, good, good. You are coming up, Sharmila and Varun. I really appreciate. Fine. So this is going to be what? Cos alpha is 0.8, sin alpha is 0.6, minus 0.6 and 0.8. This is rotational matrix. Now what you need to do? You need to multiply this 0.6 minus 0.6, 0.8 into what was the point? The point was 3, 2. So I'm going to multiply this and tell me what's the answer for this. Deepak, yes, I really appreciate your following up. You are speedy and really nice. Good, thumbs up. Okay. A is the option. Okay, fine. 3, 2. Okay. So what is this? Can you please tell me? Okay, let me calculate it. My own. Oh, I just flipped it. This is 3.6. This is minus 0.2. Okay, did I get it right? 3.6 minus 0.2. Yes, I got it right. Now, this is the coordinate system, or this is the coordinate with respect to the new coordinate system P, right? This is not with respect to this original coordinate system. So we need to shift it back to the original coordinate system. So what will we do? What will we do? When we shift it, what will we do? Add it by P. Yes, we are going to add it. We are going to add 1 and 3, right? So actual coordinates equals to 3.6 plus, what is the x coordinate of P? That is 1. And what is the y coordinate of P? That is 3. Right? So this will be 4.6, 2.8. So A is correct. Okay, so all of you, I really appreciate whosoever got A. If you didn't get the A, okay. If you didn't get the A, then even if you didn't get the A, I appreciate that at least you're there, you're trying. Okay, it will come up. Fine. Yes. Is it good? Is it good? See, where is it? Yeah, when we shifted it here, we reduce this by x by 1, right? 4 minus 1 equals to 3. 5 minus 3 equals to 2. So when we shift it back, we need to add these numbers. Just a common sense. Is that good? Hello, are you there? Is that good? These are some of the important concepts. All right, these are really important. And even if, you know, 2 marks question comes up, even 1 marks question comes up, because these are the basics. All right, then your rank, I repeat, your rank will go up. That's why we are doing this. That's why we're having this session. All right, this session is for 2 marks. Let me tell you this. Okay, yo Varun Sharma, I agree. Fine. So for now, that's all from our side. I'll see you in the next session where we'll be discussing something about the 3D. Okay, we'll take up this question. Okay, thank you very much, Dimple. My time is up. It was just a 1-hour session, and yeah, Deepak will come back. I promise to you we are going to do this. Okay, a 3D question. But right now I'll have to leave because the slots are filled up. I don't have permission further to continue this session. Okay, so I'll be back, Deepak. All right. And okay, then I hope that this session was really important to you, really mind-boggling to you. I hope that I stirred your thoughts. Okay, always remember that, you know, a good teacher stirs your thoughts. I'm not saying I'm good. I'm saying that, you know, you need to think, you need to develop intuition, you need to develop your thoughts, then only you will reach there. You need to understand, okay? You need to have a good understanding. And with this, I'm going to conclude this, and I'll see you in the next session, all right? Probably on Monday, yes. Okay? So, thank you very much. Thank you, Varun, for that amazing comment. You are also amazing. You are also awesome. And I'll go back to the quote of Kung Fu Panda where he said that a real warrior never quits. Be happy, be blessed by the divine, and give your best. Okay? Believe in yourselves. You'll get there. I'm sure you'll get there. Okay? Okay. Thank you very much, guys. Bye-bye. See you. Thank you.